taking existing copies of ideas, a very sophisticated thing, because I'm taking both the physical embodiment in the plants and the seeds, right? I'm taking the machinery that allows for genetic modification, the modification of the DNA of those machines, and I'm taking my embodied knowledge of that process of those machinery to operate. I mean, my dean, Barbara Schall, is a world-renowned leader in rice, biological rice and DNA rice research. She can do it. I don't. Even if she explained me many times at lunch how she does it, I still have a very knowledge of that. All those ideas may be public goods in the abstract, but I don't have a copy of them. So if you put me in the Monsanto lab or in a Chinese rice lab, I'm very useless, right? And whoever in China may be interested in that better learn and make copies of their idea, right? And so the new rice that comes out certainly embodies an idea, a new idea, but it was very costly produced. You understand?
Yeah.
So if you think seriously at the role of ideas in economic development, you realize that, and this is actually a Schumpeterian observation. Schumpeter has a whole section in which he talks about innovation, and he wants to make a big distinction between invention and innovation. Now his distinction is not really like mine, because for him invention is already something embodied. It's the scientist and the researcher, the poet, the designer that comes up with an idea of something new. But it's not adopted. People are not making economic use of it, right? And that's already a relevant thing. I'm pushing that argument a bit farther and make you think, well, actually, in fact, even before the invention, there is a potential idea, an abstract idea that could be discovered. And that is rivalrous. Sorry, it's non-rivalrous. I'm sorry. That is non-rivalrous because it can be discovered independently by him, by me, by you, by you, by you. In fact, many things have been discovered independently by different people, which meant some abstract idea were implemented and embodied in the first copy, in the prototype, by many people simultaneously. That's what it means. Right? If we all discover simultaneously penicillin, it means that the abstract properties, there are properties of bacteria and blah, 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 okay, that can be understood by the human mind, were understood simultaneously by him, me, you, her, and so on. And so we had 72 prototypes all together, which proves that that abstract idea is not rivalrous. But it also shows that the first copy is rivalrous and it's actually costly. Because we just don't get good ideas from the sky, we get good ideas from an investment. Okay? So ideas are not public goods. Are not public goods. They just are not. Useful ideas are not public goods. There is no way out. There isn't a single useful idea that is a public good. Not even the square root of 9 is a public good. Because you have to go to school and understand square root before you can compute the square root of 9 is 3. It's not true that everybody knows the square root of 9 is 3. Not everybody have in their mind a copies of square root of 9 is 3. Ideas are one of the most costly things that are on earth. Sure, those for which there are very many copies and are relatively simple, like square root of 9 is 3, are also easy to learn because many people can teach you, right? And therefore, it's easy to make copies. It's almost costless. We have this impression that if somebody has a notion of what an integer number is and a notion of square, we can teach them very easily at almost no cost the square root of 9 is 3. Well, funny enough, that person must have the notion of number, the notion of square, which is already non-trivial exercise. You go out in the street, you'll find lots of people that don't know the difference between an integer and a real, right? Difficult ideas are extremely costly to copy. Most of us can blubber and bullshit about quantum theory and indeterminacy principle and Heisenberg this and that. But most of us would not absolutely be able to use that. We think we have the idea, we don't. We don't have a copy of the idea, we just have some bullshit that is good for dinner time. Right? Lots of people say, oh, black holes. Yeah, the only black hole in that circumstance is in their head. Because people don't have idea of gravitational things, and I don't. I mean, I know I have vague, ugly copies in my brain of that idea by reading, astrophysics book by David Pines and so on, and try to understand, and then forget it because it's difficult stuff. It's very expensive copies of very expensive ideas that very few people know. It's not probably good at all. Not at all. If you actually, the more you look deeply at the frontier ideas that have economic value, you realize that making copies of them is super expensive. Super expensive. It requires having a PhD, and a very specialized PhD, and dedicating hundreds of hours to understanding that with very specialized people teaching you. Even economists have to spend time to learn von Neumann. Right? Imagine a very highbrow cancer researcher. In recent years I've been entertaining a lot of time with a friend who's a top researcher in immunology, in mitochondrial DNA at WashU, it's a top school, and he explains to me a lot of things and I know extremely little. Now I understand about mitochondrial DNA a little bit better than I used to. But my God, I know extremely little, and we have spent dozens of hours talking about that, literally receiving lecture from a very top guy whose opportunity cost is very high. We just have fun. I mean, I get along fine with the guy, he gets along fine with me, I explain him some of my stuff, but you understand, if the opportunity cost of that is that. So, how is it that economists have been talking for 20 years of idea as non-rigorous good, public goods, beats me. It's the most crazy, I was going with a stronger word, idea that we could have. Right? So let me actually tell you. So, if ideas are not public goods, what are they? Well, they're produced good. In fact, in some sense, they are the most embodied thing that there is. They have to be in books, they have to be in labs, they have to be in test results, they have to be in machinery, they have to be in brains, in specific neural configuration of your brain. So much so that if you, God forbid, you have an accident or you have a brain operation, that idea may be removed, doesn't exist anymore. And you may become unable to learn it, right? Because it is embodied in your neural configuration. We call that human capital. We call that, God knows, why is it that when we call ideas human capital, we think it's costly to produce? And when we call ideas ideas, we think it's a free good that can be produced for free. Isn't that funny? You understand? Ideas and human capital are the same thing. My human capital is just a systematic, hopefully useful collection of ideas. And accumulating human capital means producing new ideas, adding ideas to my stock. New ideas are the flow from which the stock called human capital is increased. Aging is the depreciation. and discovering that your ideas are wrong is also depreciation. It's obsolescence, right? When somebody shows you, hey, look, that actually is not true. The experiment proves it false. That's obsolescence of human capital, becomes useless, right? So that's one thing I want to know. So, on the other hand, somebody raised their hand and says, oh, come on. But even this, right, the time it took the Chinese guy to discover the rectangle theorem, the rectangular triangle theorem, the time it took the Greek guy to discover the rectangular triangle theorem was much shorter than the time it took us to learn it. Now that may be true. In the specific, who knows? I have seen dumb people taking hours trying to learn the theorem and still being unable to understand it. But assuming, in general, that's true. In general, it's certainly true, right? Smart people studying physics may learn about the indeterminacy principle and quantum mechanics in an amount of time shorter than it took the hundreds of researchers before them to develop the current state of that theory. Okay? So it's certainly true. What is that is true? What is true is that if I look deeply into innovation process, I have to recognize there are at least two activities. One, given K1, or let me call it KIT, right, produces the first copy of Ki plus 1t in period t plus 1. And it's at a certain cost. The second, with the first copy of Ki plus 1, produces more copies of Ki plus 1 in period t plus 2 at a lower cost. So let's call the first copy the prototype. And let's call those copies. Right? That sounds like a reasonable, generalizable intuition for most human things. Ways of doing things, type of human capital, type of machine, technologies, new ideas, new ways of doing things, new material. There is always a prototype. At least one. The fact that we use a real number, I think it's useful because it allows for simultaneous invention. Per se, in an idealized economy, there is no reason that there is only one person inventing one copy of an idea. Maybe because of price incentive, maybe because of chance, maybe because of millions of reasons, we may have simultaneous invention, so we have many copies. In a lab, or in a bunch of labs that are competing to inbreed a new type of rice, we may have the prototype to be 50 plants, or 500 plants, or 5,000 plants. Right? But they are prototypes. They are produced with a costly technology. Then we have to recognize, and again it's a feature of nature, due to the fact that humans are capable of imitating and are capable of communicating. Right? And due to the fact that things, physical things, once you make a prototype of them, can be reproduced quickly. Right? Then there is a second technology to make copies. We call that innovation, we call this imitation. It's just a label. But it makes a bit of sense, right? You introduce a new way of doing business, you introduce a new good, and I try to compete with you because we are in the same market segment, by imitating your way of producing, your way of marketing, your type of good. Right? We make phones, Apple comes up with a smartphone, we all try to make phones like Apple. Those of us that succeed at imitating Apple, and notice that whenever you imitate, actually, it's very rare the case that you just do pure imitation, literally copycat, right? You do copycat only for low-level things, only for the short periods, only for, when you are a serious business, you imitate and innovate at the same time. You also do something slightly different from them, right? So yeah, Volkswagen makes the 2 volumes Golf as a big success, gigantic, then everybody around the world, every car producer wants to make something similar to Golf, but they make their own variation. They don't make exactly the copycat of Golf, right? And so on, right? And the same for the phones, okay? But we imitate. Undoubtedly, people that looked at the iPhone and the technology underlying the iPhone and studied it, and were probably already working on that, actually, in fact, they were, probably needed less luck, less resources than Apple to come up with the first, Samsung smartphone. But think about Nokia or Ericsson, were clearly unable to do so. Motorola was unable to do so. And these were big companies that at a certain point were the dominant companies in the phone market. Nokia was, Motorola was, these were dominant companies when Apple came up with the iPhone. And so it's not even true that it's so easy to go from K1 to K2. Right? That's something that requires investigation. Now, you know, K2, some people that have K1 build K2. But some other people that have K1 are not even able to imitate people having K2. All right? So that, I understand that gives you a growth model. I sketch it only for you. We'll say it Friday better. But that gives you a growth model, right? In period T, I have technology. Let me do like I did before. So let me label periods according to the technology. So pretend we are in continuous time, right? And so for all period 1, I have technology 1. And with the production function 1 and some labor, right, I produce output. And I split that output into consumption, investment, and R&D 1. That's an option. So this allows you to accumulate more K1. This allows you to produce K2. Now obviously we need a theory. We'll do that Friday. We need a theory to explain when it is convenient to do this, when it's convenient to do this. We will see in general, if we use a simple model, you either do this or you do that. That is, you either accumulate more of the old capital or you spend resources to build a new one. By the way, it's not difficult to actually think a situation in which you do both simultaneously. All you need is some kind of decrease in return in one of the two activities. Okay? But let's not get too complicated. Okay? Anyhow, at a certain point you don't do this, you do this, and so you get K2 in time 2 as some function of the R&D you put in. And then you start a new grow process. With K2, you use labor 2 and you produce output 2 and so on. Okay? Like we described before, right? Like we described before. I'm making this very simplified, but I think it's clear what one needs to put. Is that okay, guys? What is that this thing does? It says, look, G and F are different. This accumulates 1 to 1, right? I add I2 to K2, I get more K2. This doesn't add 1 to 1. I may have to spend 10 units of old capital in R&D to get half a unit of new capital. So it could be very expensive, right? It could be very expensive. And in fact, if it is very expensive, you do it only when it's really convenient. The economic choice of, your country, even the best guys, were not assigned or found no incentive to innovate for the first 20, 30 years of growth. Why? Because it was better to use the best guy to copy, to imitate, to make copies of technologies that already existed. Eventually, once you have accumulated enough of the technology that already exists, and you have economic reason to try to get better, then you start using the best resources to innovate. But at the beginning, so the labs prop out and so on. But at the beginning, you just make copies.
Right.
Which is actually the way economic development always took place. Right? Everywhere. Everywhere. Right? Innovation takes place in some factor, in some point on Earth, and then the process of capital accumulation allows you to spread it. And the imitation and free entry there is key. Now, at this point, and that's the last topic of this lecture, so is this clear? I mean, I'm sketching it, but it's pretty much, you know, the way in which we want to think of that thing that I drew before. It's always the same graph, right? We have a ray, we have a certain technology, we hit a snag, we don't know how to grow anymore, some factors are too expensive, we have to figure out a way of becoming cheaper and more competitive, we find it, and then we accumulate again until we hit another snag. Right? Obviously, these are models, they're very simple models. In fact, because I'm not good at drawing in 3 dimension or 4, they're models with one input and one output. Obviously, in the world out there, we're doing this at a very large scale, right? We are hitting snags in the car industry, and we're trying to figure out electric cars or assembly plants that are more robotized. We hit a snag in the textile industry, you know, in China, and what you do, you either try to robotize the textile plants, or you ship the production